Hi guys, welcome back to my channel. In this lesson, we want to look at factoring complex expressions completely. This is not a complex analysis, okay? We are not talking of a complex algebra or complex numbers. We mean complex factorization, okay? How can you factorize them completely? So at the end of this lesson, you should be able to factorize complex expression completely. Okay, this is following the video we did previously on factorizing expression completely, where we use the algebraic identity. Okay, if you have not watched the video, I'm going to put a link below, so click on it, then get a hint on how to use algebraic identities for factoring. Then you can come and work this one. So let's continue with this lesson. We are going to be starting with examples, just examples. So factorize the following expression. Factorize the following expression. So example number 1 says x raised to the power 4 into 4 into 2x plus 1 raised to the power 3 into 2x plus 2x plus 1 raised to the power 4 into 4x cubed. Okay, so you can see this expression that in the first term we have about a 1 2 3 4 4 bracket. In the second term we have 2. So the first step you should take when you are factoring this kind of expression is to factor out the common factor. Okay, so you can see that 2x plus 1 is in the first term, 2x plus 1 is also in the second term. We have 4 here, we have 4 here, so we can combine this 4x cubed. So this 4x raised to the power 4 can be combined thus, plus into 2x plus 1 raised to the power 3 into 2x plus 2x plus 1 raised to the power 4 into 4x cubed. Okay, so do not expand everything and collect like that. It will be too cumbersome. So just factor out the common factor, then you can simplify. So to the first term, 4 is common. Okay, x4 is here, we have our x cube here, so of course x cube will be common, and then we have 2x plus 1, 2x plus 1 raised to the power 3 here, and raised to the power 4 in the second term. Of course 2x raised to the power 3 will be common. Then we can put the remaining term inside the bracket. So if we take 4x cubed in 4x raised to the power 4, we have x. Take 2x plus 1 cube here, we have nothing there. Then we'll be left with 2x here, plus take 2x plus 1 raised to the power 3 in 2x plus 1 raised to the power 4. We have 2x plus 1, and then 4x cubed in 4x cubed will be gone. So now we can expand the square bracket. 2x plus 1 raised to the power 3. So if we expand the square bracket, we have 2x squared plus 2x plus 1. Okay, and let's see if we can factorize this further. We cannot factorize this expression further, I don't think so. 2x squared, is there any two number we can multiply to have 2x squared and add to obtain that? I don't think so. So guys, this is the complete factorization of the expression. Example 2. X cubed into 3 into x squared plus 1 squared into 2x plus x squared plus 1 raised to the power 3 into 3x squared. So follow the previous step we used in factoring the first one. Factor out the common factors. So here we can multiply this out. 3x cubed into x squared plus 1 into 2x into 2x bracket. This is x x squared plus 1 square into x squared plus 1 raised to power 3 into 3x squared. Okay, and of course we can take the common factor now. Common factor is 3x squared and then x squared plus 1 all squared. So taking 3x squared from 3x cubed will be left with x squared plus 1 squared, will take that, then we'll be left with 2x here, and then here we'll be left with x squared plus 1, and then 3x squared and 3x squared will be gone. So we can open this square bracket now. 3x squared into x squared plus 1 all squared into 2x squared plus x squared plus 1. Okay, so we can collect like terms over there into x squared plus 1 squared into 3x squared plus 1. Okay, and then we cannot factorize this expression further, so this is the final answer. Example 3. 2x minus 5 raised to power 4 into 3 into 5x minus 4 raised square into 5 plus 5x minus 4 cube into 4 into 2x minus 5 cube into 2. So we can take out the common factor first. Okay, or let us multiply the numbers. 3 times 5 times 2, this will be 30. Oh no, yeah, not 30. 3 times 5 is 15. 2x minus 5 raised to power 4 into 5x minus 4 raised to power 2 plus 5x minus 4 raised to power 3 into 2x minus 5 raised to power 3. 4 times 2 is 8. So we can factor out what is common. Of course, 8 is not common, 15 is not common, but 2x minus 5 is common here, cube, yeah, and 5x minus 4 is also common, square. So then we can take the remaining one, 15 into 2x minus 5 plus 5x minus 4, yeah, so 5x minus 4, no, there can't be 5x minus 4, yeah, 5x minus 4 square in 5x minus 4 cube, we have 5x minus 4, and 2x minus 5 cube in 2x minus 5 cube will be left with 8. So we can expand the square bracket. 2x minus 5 raised to power 3 into 5x minus 4 raised to power 2 to 30. 30x minus that should be 75 plus 40x minus 4 times 8 is 32. Okay, so we can collect like terms in those brackets. Collecting like terms in those brackets, that will give us yeah, collecting like terms in those brackets will give us 2x minus 5 raised to power 3 to 5x minus 4 raised to power 2 into 70x minus this can be 107. Okay, and then we cannot factorize this expression further, so this is of complete factorization of the expression. Okay, 8 times 4. Yep. Example 4. X squared minus 5 cubed all cubed multiplied by 2 into 4x plus 3 multiplied by 4 plus 4x plus 3 squared into 3 into call it this way, into x squared minus 5 x squared into x squared. Okay, so taking out the common factor, the common factor first of all is x squared minus 5 all squared. It's common here, and then we have 4x plus 3. Okay, so if we take x squared minus 5 in the first one, we have x squared minus 5, okay, multiply by 2, 4x plus 3 in first plus 3 will be gone, and then will be 4 multiplied by 4, then plus 4s plus 3 here will give us 4s plus 3, okay, and x squared minus 5 there will finish, and then we are left with 3x squared. So we can open the square bracket there, x squared minus 5 into 4x plus 3 into this is 8x squared minus 40 plus 12x cubed plus 9x squared. Okay, I believe we are right here. So we can collect like terms all through x squared minus 5 squared into 4x plus 3 into 8x squared plus 9x squared will give us a 17x squared plus 12x cubed minus 40, and then we can rearrange the term over there to have 4x plus 3 into 12x cubed plus 17x squared minus 40, and 12x cubed plus 17x squared minus 40 may not be factorized further. I don't think we can factor that further, so that should be the answer. 12 times 4 is 48, 480. Is there any two number we can multiply to have minus 480 and add to have a minus 27? I don't think so. So let's leave the answer this way. The complete factorization. Number 5. Number 5, or 4 into 2x plus 3 squared minus 4x minus 1 into 2x plus 3 squared all over 2x plus 3 all raised to power 4. So we can factorize the numerator to obtain if we factorize the numerator, we have 2x plus 3 all squared. Then the first term we left with 4, the second term will be left with 2 into 4x minus 1 all over 2x plus 3 all raised to power 4. So 2 here, 1, 2 here, 4. So that has cancelled, and the numerator can be simplified to be 2 times 4 we have minus 8x, minus 2 times minus 1 we have plus 2, all over 2x plus 3 all squared. Okay, and that can be rewritten as 4 plus 2 is 6, 6 minus 8x all over 2x plus 3 squared. Okay, and this can be simplified further to give us 3 minus 4x all over 2x plus 3 all square, and then this can be factorized for that, so we have the complete answer. Okay, so the next example we'll be looking at is a geometry. Okay, factorizing geometric expression, example 6. So it's a geometry. Say write an expression in factor form for the area of the shaded portion. Write an expression in factored form for the area of the shaded portion. Okay guys, so this we have a circle, we have one of the circle to be okay, so I'm just going to draw a rough sketch of the circle. This is the bigger circle and this is the smaller circle. So we have the radius of the smaller circle is r, and the radius of the bigger circle is r plus 2. Okay, and of course all these regions are shaded. All these places are shaded. So we are looking for the area of the shaded region. So this is what we are going to do, guys. So we'll start by calculating the area of the big circle. Area of big circle, let's call it AB, and area of the small circle, we call it AS, and shaded area we call it A shaded. Okay, so with this step, let's calculate what we have for the big circle. Area of the big circle, we know that area is pi r squared. Okay, and the radius of the big circle is r plus 2. So we have AB equals to pi into r plus 2 all squared. If you apply the identity theorem to expand this, you have r squared plus 4r plus 4. Okay, and that is the area of the big circle. Now we can calculate the area of the small circle. Area of the small circle, which is pi r squared. Okay, and radius of the small circle of course is r. So the area shaded, the shaded area is area of the big circle minus area of the small circle, which is pi into r squared plus 4r plus 4, okay, minus pi r squared. Okay, factor out pi, which is common. We have r squared plus 4r plus 4 minus r squared. So r squared minus r squared will clear off, and then we have 4r plus 4. Okay, so if we factor out 4, we have 4 pi into r plus 1, and this is the factored form of the area of the shaded region. The last example, example number 7. Okay, we have a triangle, the same, calculating the area of the shaded region. So we have this triangle. The whole of this place is shaded. Okay, so the radius of this place, the length of this place is 5. Okay, and the length of the whole triangle is 5/4 into x plus 3. Okay, the length of this place is x plus 3 as well, and the length of this place is 4. Okay, so we have AB and A small. So AB for this one, area of the bigger triangle is half base times height. Okay, the base of the bigger triangle, of course, we know it is 5/4 into x plus 3 times the height, which is x plus 3 as well. Okay, yeah, so nothing can cancel out, so this can be written as 5/8 into x plus 3 squared. So area of the small triangle is half base times height, and then we have the base of the small triangle is 5 and the height is 4. So 2 here, 1, 2 here, 2, which is 10. So area of the shaded portion is area of the big triangle minus area of the small triangle, which of course is 5/8 into x plus 3 squared plus 10. Okay, and of course this expression minus 10 rather, minus 10. So this expression cannot be factored further. So this is the factored form of the area of the triangle. So I believe you understood. If you have any question, do not hesitate to put your question in the comment section below, and remember to subscribe to this channel so you can have a copy of our next video. Bye.